In this particular lecture, we'll be discussing what is safety instrumented system with the help of a practical industrial example and how it is basically represented in the P&ID. So we'll be discussing these two things. So let's begin. Okay. So we are going back to same example which we have used for the BPCS system. So you remember in the case of the BPCS system, uh, so this is basically a vessel. So let's begin with the process first. This is basically a vessel, and the maintaining the level of the vessel is critical because it should not go to overflow or overspill that may cause the safety issue, and it should not go below a certain level so that my downstream process get impacted. There may be some process where the low flow can. So suppose if this vessel is at the inlet of your furnace, right, and the low flow in the furnace may cause the meltdown of the pipes, right? So you want to avoid the low flow there, and how you can avoid by maintaining the proper level here first. Obviously, there also will be there some protective measures, but if you can protect it beforehand, then that situation does not happen itself, right? So basically, what happens is you want to maintain the level here, and for maintaining the level, what have been done? We are measuring the level first. The level measurement instrument is generating PV. There is an operator which is giving you the set point, and the set point goes to this level uh, valve, and it is getting open or closed depending on the level, right? And in most of the cases, this is how the level is maintained. Now, say there is some disturbances in the downstream or upstream, and there is a certain fluctuation in the level, right? Maybe the flow that is coming in the inlet, there is a sudden increase because of the upstream flow meter does not work or something else. Okay. So in that case, level goes high little bit, level goes higher, and there are basically alarms, right? So there is high alarms, low alarms. And these alarms operator can see here, L, H, H, right? So first you see the first layer of protection is your BPCS, right? Your basic process control system. After BPCS, you have an alarm, right? Suppose alarm after alarm, the operator need to respond and the take action so that the level does not go to overspill or underspill, right? But it will also take some time. So if this is fluid is coming from some other unit, what operator needs to do? Operator needs to inform that other unit operator through phone or something, and then they will go into the field, check what is happening, and they take the corrective action. And it may take it may take 30 minutes, it may take 1 hour or more, right? So by the time the action is taken, the level goes high up, right? And it may cause the overspill. In other cases, it may also happen that the disturbance is so much that there is no time to respond for the operator, right? And before the operator responds, uh, the action is taken place. So this is a concept called process safety time. So what is your process safety time, right? Process safety time is there is some abnormality. What is the time within which you should respond to make the process back to the safe state? It will depend on multiple different things. What is your line size? What is the maximum disturbances this flow can bring to? What is the size of the vessel and everything? So this is the calculation that is done very initially by the process designers, and that gives us the process safety time, right? Okay. not going into too much detail here. So basically, what you need to do is need to protect your system from the overflow or the underflow, right? So for example, for this particular example, let's consider the low flow is a critical, low level is the critical, and that is what you want to mitigate, right? Or prevent. How you will prevent? You will prevent through uh, a safety instrumented system, right? So you have first your BPCS, basic process control system, then you have alarm, but these two are not enough to prevent your safety situation, right? So that's why you need another layer of protection, which is known as the safety instrumented system, right? So what it will happen, there is another set of LT which will sense the LT and sends the signal to an PLC, right? Programmable logic controller, or you can also, as it is a safety action, it is goes to a safety PLC. Now the safety PLC generates a signal and gives back to a on-off valve, right? Now on-off valve is equipped with a solenoid, right? So in the solenoid, there is one side the air is coming, and one side it is going to the valve and another side it is basically venting out, right? So whenever there, I mean, under normal operation, the air directly goes from this side to this side, okay? So there is no problem. So air is going from this side to this side, there is no problem. But whenever there is a low signals, that what will happen, that will close the solenoid, right? This will close the solenoid, and what will solenoid do? Solenoid will vent it out the air. So there is a dearth of air in the pneumatic actuator. So this is your actuator, right? And the valve will go to its fail position. Here in this valve I have not shown the fail position. Suppose the fail position is a close, right? So this is the fail position of the valve is close. You can write it here, fail close. For this valve also it is fail close. So this is a fail close valve and the valve will get closed. Now when the valve get closed, there is no drainage of further liquid, right? So obviously if the inlet input flows in the same fashion, the level will continue to raise. Okay. So So the situation of low level is mitigated, and this is done by this safety instrumented system. So all these things, so starting from this level to this uh, your PLC, all these wirings, everything, this valve, solenoid, right? This every bit of it is part of your sys, right? So this is basically, this whole thing is called your sys, right? And the other portion, if you see this thing, this level transmitter, this DCS, and this final control element, this is your BPCS system. And there is another thing, there is uh, these alarms, right? This is alarms. So these alarms, these are alarms. So these are also another layer of protection, right? Even after that, so these are all the prevention layer, right? Prevention layer. Suppose even after that, this action, the disturbance becomes so fast that level still goes toward the lower side, right? So uh, there is no possibility of any other prevention mechanism. So there can be some mitigation layer, which can be fire and gas system, which can be some dike wall kind of a thing. So they are mitigation layer. So this all of these things are called layer of protection, right? So for this layer of protection and for the safety system, we have a complete separate course or playlist which is called the functional safety. So if you are interested in the functional safety, you can take a look at that course or that playlist or that videos where we have clearly given you more and much detail how this safety system look like, what is the process safety system, what are the layer of protection, how the LOPA is done, how HAJOP is done, how the SIL calculation is done. Everything is clearly mentioned there. So if you are interested, you can watch these videos or enroll for that course. Thank you.